The topic that we've been asked to address by the Academy today is the topic of screening patients for issues with restorative materials. By way of full disclosure, materials reactivity testing is provided through Clifford Consulting and Research, and I am the inventor and developer of that testing regimen. I have a financial interest in this testing. I own the company that provides the testing. I do not provide any specific grants to the Academy or other financial resources or aid to the Academy. I do not charge the Academy for making these presentations. I would like you to know that the IAOMT does not have a financial interest in materials reactivity testing, in testing promotion, or in Clifford Consulting and Research. In full disclosure then, would you understand that this testing is mine, and if you use it, it is to my financial advantage. Have we been sufficiently clear in that, or do you have any questions about it? About screening testing, can materials really be a serious issue? We know that in this day and age, people go to the dentist has 4 or 5 materials that they like to use and are very familiar and comfortable with. And depending on whether it's going to be a small occlusal surface, or whether it's going to be a root canal, or whether it's going to be something else, they have a product that they wish to use and they're familiar with using. There is something desirable to be said for that experience and training. What we learned very early on is that most of our modern materials are very technique sensitive. And so when it becomes necessary to use a different product for some reason, there is a learning curve and often a resistance by the office to invest in a material that they don't commonly use. Some offices will do that to humor a favored patient. But we should recommend and suggest to you that there are some very serious issues that can arise from materials. How risky are materials for normal patients? For most normal patients where we're doing some minor maintenance dentistry, they probably can tolerate a wide variety of things, even products for which they are sensitive. Our bodies have been designed to accept some insult, and so it is acknowledged that there will be a patient that can use a zirconia in their restoratives that may have a zirconium reactivity. They cannot use an underarm antiperspirant because they react quite severely. But they could still perhaps because of the slow offload that will occur from that zirconia. Can screening patients for reactivity in advance really catch all materials-related issues? And the answer is frankly no, it can't. What then do we do screening testing for? It gives us an opportunity to eliminate things that are most obviously and blatantly reactive in this patient. If the patient has a severe problem with nickel, it is entirely feasible that we will see that in testing. If they have an issue with cadmium, we know that there are some denture materials that we're not going to use because of the pigmentation system. Thankfully, most of those companies are now going to carbon-based dye, and we're getting out of the metal pigmentation issues. But there are still a few products out there. If this patient is a true universal reactor, where their sensitivity is at a cellular membrane level, does not pass through the immune mechanism, does not stimulate a strong antibody production in an attempted defense, screening such as we offer is not going to see it at all. And so there are some issues. If the patient hasn't been exposed to something for a long time, well, you say, the patient has never had green widget restorative in their teeth. How can you know that they're going to react adversely with green widget? If I know that they have a phenols issue, or they have trouble with an issue in urethanes, or I know they have issues with other components because of food containers, things they eat, water, lifestyle exposure, workplace exposure, most of the things in our restoratives today are broadly enough scattered that if a patient is going to react to the common components, we should see it in screening. But please know that there are issues that screening just cannot find. What we can still do is to narrow the spectrum of choices. And so there may still be usefulness in this kind of screening. What about simple cases? Again, as we mentioned a moment ago, screening may not be necessary. The body may be able to take care of a small insult and go breezing right on down the way. We'll speak momentarily about body thresholds. And if we have not acquired a threshold, patient may never know the difference. And so frankly, there are those cases where you can make a good educated guess and do just super for that patient. Restorative suitability is usually judged on factors such as economics, physical requirements, durability, and aesthetics. This stuff works well, it's strong, it has a great shear strength, it's ductile, it's malleable, it does exactly what I need it to do. And therefore, mechanically, it works perfectly. Those are the common bases by which the doctor normally will select a material and say, this is what we will use. But not every product is equally well suited for every patient. It should be noted that immunology, physiology, biology, and existing placements are also critical factors. You don't believe it? Put a zirconia crown on with a good strong aluminosilicate bonding agent. Galvanically, they will go to work on each other. Could we dispel one myth early in this presentation? There is no such thing as an inert dental restorative. Admittedly, there are some which are far less susceptible to this than a frankly reduced metal in a bridge or a metal crown. But they will interact electrically, galvanically. And frankly, you are in just as much difficulty if you put a high palladium noble gold in the mouth and the patient happens to have a chrome cobalt hip replacement. Galvanically, right down the vascular bed, they will interact with each other. From the hip, we start getting some 6-valent chromium being released. Patient begins to have problem with glucose and glucose metabolism. And in terms of what's in the mouth, the palladium starts to come out. We have a nasty taste. There is irritation along the buccal fold and other areas. And the patient never associates this having trouble with the hip. Certification, seals of acceptance, seals of approval, and identiloid tags do not guarantee that a certain product will work for every patient. What do we do to get a certification or a seal of acceptance? Number one, the newly revised ADA ANSI Document 41 has all of the tests that a material must pass to be found safe and effective. Please note that in many of the tests that material goes through, it does not have to have a perfect score. In fact, some of them can almost be flunked, and we can still market the product if we put a notice in the product insert sheet. And if this happens to be one of those sensitive patients or a patient that will have difficulties, the seal of acceptance says this manufacturer has passed the certification testing within the acceptable specified rules. There is a good quality process at the manufacturing site. They put in the ingredients in high purity that they claim to put in, and if used as specified by the manufacturer, it will produce a restorative mass as we say it will. Please note that at no time or place in all of that discussion does anyone say it will be perfectly tolerated by all patients. And so simply because it has been accepted by some of the alphabet authorities does not mean that this patient is going to get along perfectly with it. And sometimes great, well-suited products become a problem when placed in a mixed restorative environment. If I put Admira here and a lava crown here, you're likely to have some taste issues, some metal taste in the mouth. Well, I haven't placed any metal, you say, but you have. We need to dispel another myth. There is no such animal in existence as a metal-free restorative. I don't care who advertised it. And frankly, a good chemist driving by a dental facility that sees the advertising that says, we have only metal-free restoratives, wonders who slept through that lecture in freshman chemistry about anions and cations. Anytime there is an anion in nature, there must of necessity be a balancing cations, and those are nearly always metals or metalloids. And so there are going to be metals. The difference, in a shiny metal crown, we have fully reduced metal. In a composite, we have fully oxidized metal, but they are metal. And because they are oxidized does not render them wholly inert. Less reactive, yes, but not inert. And so sometimes the doctor has fixed this tooth, and the doctor before that fixed that tooth, and the doctor before fixed another tooth, and what we end up with is a zoo. Any one of the products would have worked perfectly for this patient, but the mixed etiology becomes an issue. A list of ingredients does not always reflect the nature of the finished product. Formaldehyde is a nasty chemical beast, no matter how you slice and dice it. And yet, formaldehyde is the backbone of acetyl resin. And when properly cleansed using some warm saline and then followed by warm distilled water soaks to make sure we have no unreacted, unpolymerized formaldehyde remaining, and acetyl resin is the empirical choice for denture material for a violently reactive or universal reactor patient, made of formaldehyde. You see, if all I do is look at the ingredient list, I may know nothing about what's going to finally be in the mouth. We had a wonderful presentation here today on bisphenol A, and everything that has been said about it is absolutely true. It's another nasty chemical beast. Oh, you say, I've got those that don't say bisphenol in the list of ingredients. I am free of that trouble. And when I hear that, I want to say, and they lived happily ever after. Folks, because it is not a purposeful originating component, does not say that it will not be part of an intermediary chemistry that is formed in the polymerization process. What then do we do? Get rid of all the composites and the like? No. Here is where we find out who knows how to cut the mustard. Quality dentistry, fine technique, care in caring for your patient will help to make the difference. If it says mix 1 part A and 1 part B, that's what it means. If they are slightly mismixed, we got a little too much of one and a little too little of the other, the polymerization process does not go to completion or is very slow to complete. When that happens, your patient's going to get exposed. Thankfully, we have twin barrels and other such inventions today that kind of make it a little easier. There was a reason those were invented, and it wasn't wholly convenience. Let me suggest to you that the use of a dam, the use of fresh air to the patient, the use of high-speed air evacuation, We have some folks here demonstrating products at the show. You ought to look at those if you don't yet have solutions that provide these features. Water and suction where appropriate. These are the techniques, and if it says put the light on 60 seconds, don't quit at 50, because the gal in the next chair is starting to come out of the anesthetic. Let me suggest to you that if it says the light must be 450 nanometers, that doesn't mean your super triple whammy light that takes care of everything but happens to put out at 680 is not going to properly initiate the polymerization as it should. When the manufacturer says use this light or this wavelength for this amount of time, there is a reason, and it's not just to sell lights. Folks, if you will do these things, do we eliminate the bisphenol and other such issues? By the way, bisphenol isn't the only one. Do we eliminate them? No, we do not. But we can minimize them to the point that the contribution may well be within the patient's ability to absorb some insult. Bisphenol, carefully placed, cured, and put into the polymer, behaves somewhat like formaldehyde in the polymer. Once it's in the polymer, it does not behave in the same way at all. If it is not fully reacted, if you did not treat it properly, if it has not outgassed or offloaded properly, you have an issue. Let me suggest that in all of these things, fine technique in dentistry will reduce the risk to your patient. I will very straightforwardly tell you that I do not know of a product that is 100% safe, not one. Sometime when we have time, we ought to talk about zinc oxide. Do they get any more basic than that? Now, folks, in this particular process, form is vastly more important than absolute content. People get crazy about aluminum. If it's there as a silicate, an oxide, an alumina, we totally ignore it unless the patient's also silicate sensitive, and those are very rare. There is more aluminosilicate in a single side serving of fresh leafy green garden salad than is likely to be released from an entire mouthful of aluminosilicate ceramic or porcelain in a 10-year span. Let's put these things in perspective. Form is important. There is no such animal as a metal-free, and nothing is completely inert. Intact materials are virtually never a problem. Properly reacted constituents are seldom a problem. Complete similarity throughout the mouth reduces potential problems. And frankly, reduced metals behave very differently from oxidized metals. Reactivity and toxicity requires acquisition of one or more thresholds. They can be masked by compensatory mechanisms. I can be sensitive to something, and yet I have an alternate way to accomplish the endocrine function or the energy exchange function or wherever this thing is interfering. But at some point, I will saturate all of those processes, and when I do, I acquire the threshold. The reaction is not going to be gradual. It'll go like this up to the threshold, and then in a linear fashion, everything goes to Hades in a handbasket. It is sudden onset when you saturate everything completely. Symptoms and loss of function then are not linear. And sometimes, if a patient isn't getting along with something, I really do not like NiTi wire that is just the darling of orthodontics. Sometimes life is not perfect, And I've got to have that kind of strength that I can't get from Invisalign and from sapphire brackets and from this ceramic wire. I've got to have something stronger. When that's the case, get on it, use it to the maximum capacity, and get it out. Life is not perfect. And sometimes you may need to use something that's contraindicated in screening. But at least you and the patient know that there are symptoms that should be watched for when that happens. Sporadic symptoms. If I am at or near a threshold and I bump up and down through it, I feel horrible this morning. By lunchtime, I'm on top of the world, and this afternoon, I'm going to feel horrible again because I am bumping through a threshold. And when I come underneath it, I'm fine. If you have a patient that has to use something that is not well suited, sometimes there are other areas in lifestyle, diet, and in whatever that we can reduce the body burden so that whatever is being contributed by the restorative is not going to be an issue because there is still compensation up to threshold. Corrosion byproducts, outgassing and offloading, improper and incomplete mixing in curing, dissimilarities in mixed etiologies, microbial presence, and diet are the primary areas that we can identify where reactivity issues start. And please, not every issue is caused by dentistry. It's simply a matter that if the patient does have a sensitivity, we don't want to make it worse by putting something in they already have a sensitivity to. And so before you get the idea, my gosh, my profession is horrible, that isn't the truth at all. It is simply an issue that we do need to be cognizant. And here is where, particularly in a more complex case, screening can be useful. I find out a lot about the patient through the patient history and questionnaire. Have you ever had a broken bone that had to be replaced or fixed by a bone implant, by pins, plates, and screws? Do you have an artificial knee? Do you have a hip replacement? Have you had fixation in your spinal column by your orthopedic surgeon? That ought to be in the dental questionnaire. Why? Because they are using titanium niobium aluminum alloy in spinal fusion devices that does not get along with titanium vanadium aluminum that you're about to implant. They don't get along at all. You need to know that before you select the solution. Implant list from the entire body, physical exam and clinical sensings, and laboratory testing indications can all be useful. Here at the meeting, we've talked about porphyrin testing. There are some other things that can be done to evaluate the patient, and certainly a knowledge of materials is as valuable as anything else I know. What's in zinc oxide eugenol? A ZOE cement, what's in it? Zinc and eugenol, right? What about the acetates? What about the carboxylates that are used in buffering and in facilitating controlled formation and drying? What about butyrates, which can also be included? What about silane and silicate content? What about? The list goes on and on. I think the simplest zinc oxide that I know of has about 5 antigen groups that we are concerned with in screening. Adverse chemistry aspects, alteration of physical tissue structures, infective and microbial issues, electrogalvanic consequences, and esoteric field effects. All are important in evaluating your patient for the risk that you may be placing them in. What on earth is an esoteric field? We've talked about this in previous presentations to the Academy. You can get a recording if you want to go into depth. You ever had your patient come in and say, you know, KZZZ, that radio station down the street, man, I hear that all the time since we fixed this tooth back here with that crown. And I can't get it out of my head. It's there when I sleep, it's there, and you say, oh, it's all in your head. And somebody says, no, right now they're having the news and somebody just smacked into a school bus down at Elm and First Street. And sure enough, you turn on the radio and that's exactly what they're talking about. Oscillatory moments can be set up in esoteric fields, fed to the auditory nerve, and the body in many cases can interpret them. This is not unknown, folks, and it ought to be part of our process. A review of the patient history and questionnaire is useful. Patch, pellet, and subcutaneous injections can be helpful in evaluating the patient. Inhalation and sublingual changes. If you have a good allergist or environmental physician that you network with, these are tools that they will probably suggest and recommend for evaluating your patients, especially those that may be a little more sensitive. Electrodermal evaluation, you know, I don't know how, I just truly do not know how it works, any more than I know how kinesiology works. I can only tell you that I've seen too much good done by people who are expert, not the guy that spent a day in a weekend course learning to do it, but people who truly know what they're doing. I've seen too much good done. My own osteopathic physician uses some of these techniques. I can't explain it, but I can't ignore it. If you have multiple modes of evaluating your patient, use them. And if any one patient says, leave blue widget alone, take it off the list right there, whether the other methods picked it up or not. It's that simple. Cytotoxic testing has had a black eye because it's been used in ways that it shouldn't have. People tried to make it do what it wasn't intended to do. But if you have a good lab that can do cytotoxic testing, this is one way that a patient can be evaluated against what you're intending to put in their mouth. Lymphocyte transformation testing, the ELISA-ACT test that Dr. Russell Jaffe offers, the MELISA test that's offered through Dr. Vera Staskel in Sweden. If you need to know degree of reactivity, this is one way you can go about it. Harvest lymphocytes, culture them, prepare them, do a timed, controlled presentation challenge, and follow the steps that happen in lymphocyte transformation. Now, folks, that's great immunology. Let me suggest it is a little expensive, and it generally applies only to the metals. The last I checked, one of these tests for a panel of 15 metals was running about $2,700 or $2,800. So it can be used if you really need that kind of data. It's there. Lymphocyte viability alteration can be useful. Necrosis evaluation, porphyrin testing, and finally passive antibody testing. That happens to be what we do in our screening. May I suggest I use that word advisedly? It is a screening test. We cannot say that this is the least reactive and this is the most. It is simply a screen to say this patient has encountered cadmium. It has been noxious for their system. Their immune system attempted to defend and has produced antibody that is not down in the noise level, but is at or above a clinical relevance threshold. If you can avoid using something that has cadmium in it, you ought to do it. If you can avoid it, get it in, get the job done, and get it out. That's what simple screening is about. It detects post-toxin secretion. I do not have to have the toxin still present. Where did this testing come from? Working in military lab at the Army's Natick labs just out of Boston during the Vietnam War period. We had soldiers that had been exposed to some nasty things like dioxin, and we would try to find the stuff, and you could not find it in their tissue anywhere. But we learned that there would be an antibody present in IgG and IgM classes that said there was a systemic reaction against it. I know they've been exposed, and it was heavy enough to elicit a response. That's the basis from which this testing drew. To date, we have tested more than 45,000 patients. And in January, we released the same kind of test we do for dental products for the orthopedic surgical market. This testing is repeatable and demonstratable. It is classical laboratory technology. It is irritant source independent. The antibody does not tell me how much nickel is in the patient. It says the patient doesn't get along with nickel. After that, it doesn't matter. Broad spectrum findings. Storable if needed. We can freeze the specimen. We do this routinely as part of our quality control system. Pull the specimen up down the way and see if we can still get the same answers. What are the weaknesses of this kind of screening? The findings are qualitative only. It's like being pregnant. You're not slightly pregnant or extremely pregnant. You're pregnant. End of statement. You're sensitive or you're not sensitive. There is no degree of reactivity data. Cross reactions are possible. I promise you faithfully that if either cadmium or beryllium come down, the other comes down automatically because their antibodies interact with each other. False negative findings. If it's been a long time since somebody has had an exposure from some source, the antibody titer drifts down to a point that we can't detect it anymore, and yet a fresh exposure sends it off the end.